Everyone, this is Bhargav Suthar, and in today's session we will discuss what is a addition modulo and what is a multiplication modulo for groups. Okay, so first of all, let us understand what is a addition modulo m. Fine. So it is written as like this: this a plus subscript m b. Okay, or this a plus b mod n. Fine. And how it is defined? So it is defined as this a plus m b equals to r, where r is in between 0 to m, where this a and b are integers and m it is a positive integer. Now r is least non-negative remainder when the ordinary sum of a and b it is divided by m. So let us discuss example. So how to calculate? So for example, if we want to find this 14 plus 6 and 8, so what we'll do, so we'll add this 14 and 8. So first step is 14 plus 8, so that is 22, percentage 6. So if we divide 22 by 6, so then the remainder it will be 4. So 14 modulo of 6, 8 equals to what? 4. Fine. Now in same manner, if we want to find this 9 plus 5, 3. So what we'll do, 9 plus 3, so that is 12, percentage or modulo 5, so that is 5. Now 12 divided by 5, so if we take 12 divided by 5, so the remainder will be 2, so the answer is 2. So this is how you can find the addition modulo m. Okay, now suppose we have the negative number, so minus 23 plus 3 and 3, so the same procedure. So minus 23 plus 3, so that is minus 20, so minus 20, right? Now minus 20 by 3, so the remainder will be what? So that means minus 3 star 7, so that is 21, minus 21 and plus 1, so remainder is 1. So this is how you can find the remainder for negative numbers, or this is how you can find the addition modulo. Okay, now what is the multiplication modulo? The same procedure. So it is written as what? This a star or cross pm. Okay, it is defined as a star p equals to r, same procedure. R is in between 0 to p, where a and b are integers and m is positive integer, or here p is a positive integer. Now r is it is the least non-negative remainder when the ordinary product of a and b it is divided by p. Okay, so there is a correction, it is divided by p. For example, 8 cross 5 3, or 8 multiplication modulo 5 3, so the answer will be 4. How? So 8 into 3, so that is 24. Now if we divide 24 by 5, so that means the remainder is 4, so it is 4. Now 4 multiplication modulo 7 2, so 4 into 2, that is 8. Now if we divide 8 by 7, so remainder is 1. So this is how you can find the multiplication modulo. Okay, now let us discuss example. So let g equals to 0 to 5, then prove that this g plus 6 it is an abelian group. Now plus 6, so that means addition modulo 6. So first what we'll do, we need to find the whole the table. Okay, the whole multiplication table, so or multiplication modulo table. So plus 6, we have elements from 0 to 5, so in column it will be 0 to 5 and in row it will be 0 to 5. Now how to calculate? So see, 0 plus 6 0, so 0 plus 0, that is 0, and if we divide 0 by 6, so the remainder is 0. Now 0 plus 1, so 1 divided by 6, so 1. So for this row it will be same. Now consider what? This 1 plus 4, 5. Now 1 plus 5, that is 6, and 6 divided by 6, so remainder is 0, so it will be 0. Now in same manner, up to what? Up to 6, all the entries will be same. Now here consider this 2 plus 4, so 0. Now see, 2 plus 5, so 7, and 7 divided by 6, so remainder is 1, so here it will be 1. Now in same manner, 3 plus 0, 3, so it will be 3, it will be 4, it will be 5, here it will be 0. Why? Because 3 plus 3 6, so remainder is 0, then 1, then 2. So this is how you can calculate the modulo table, addition modulo table. Now we want to find, or we want to check it is an abelian group. So for abelian group, we all know that what are the properties. So that is what? The closure property, associative property, then existence of identity, existence of inverse, and the commutativity. Okay. So first let us discuss closure property. So as you can see that in table, each and every element belongs to the given set, that is G. So it is an abelian group. It is very obvious. So all the entries in the composition table are elements of the set G. So it is closed under what? The addition modulo 6. So it is closed with respect to the addition modulo 6. Okay. Now associativity. So for associativity, for every ABC belongs to G, this A plus 6, B plus 6, C equals to, if we change the brackets. So how to do that? So it is true. For example, if we take A equals to 1, B equals to 2 and C equals to 3, then this 1 plus 6, we are just writing instead of A, B, C. So it will be like this. Now what? See, 2 plus 3, 6. So 5 by 6. So it will be 5. Now 1 plus 5 divided by 6. So left hand side will be 0. Now in same manner, 2 plus 1. So that is 3. And 3 modulo 6. So that is what? 3. Now 3 plus 3, 6. And 6 divided by 6, 0. So both the entries will be 0. Okay. Now existence of identity. So here 0, it is the identity element, as for any element in the G, we can see that this 0 plus 6 A equals to A. So as you can see that from the table, it is the identity element, because the element itself plus what? 0, it will be the same element. So as you can see that it is 0. Now for 1, where is 1? So 1 plus 0 is 1. Now for 2, where is 2? So this column, consider this column. We are getting the same elements here. So it is what? This 0. It is the identity element, right? Now what? Yes. So it is the identity element. Now for existence of inverse. So existence of inverse. For every A belongs to G, there exists B belongs to G, such that. So for that, this A modulo 6 B equals to the identity element, but we have the identity element is what? 0. So we need to find B such that the element plus modulo 6 or modulus addition modulo 6 and one element, so that is the inverse element, and we'll get the identity element. So consider the table itself. Okay, from the table we'll get the answer. So that means what? Suppose we have 1. Now 1 plus some element equals to 0. So we have 1 and the answer is 0. So that means what? Here we have 1 plus 5 is 0. So that means 1's inverse is 5. Now 0's inverse is 0. Now here 2's inverse is what? 4, because we have here 0. Now 3's inverse is 3. 4's inverse is 2. And 5's inverse is 1. So they are the inverse elements. Okay, so each and every element got the inverse. Yeah, it is the same thing we have discussed. Fine. So inverse exists. Now the last one, commutative property. So it is commutative as the corresponding rows and columns are identical. Okay, so there is no need to worry about it. So it is commutative. So hence all the 5 axioms are satisfied. So hence this G plus 6. So that means addition modulo 6. It is an abelian group. Okay. Let us discuss another example for multiplication. So prove that G equals to 1, 2, 3, 4, 5, 6. It is a finite abelian group of order 6 with respect to multiplication modulo 7. Okay. So all the things are same. Just we need to construct a table using multiplication modulo. Fine. So this is how you can write the table. Here we have the multiplication modulo 7. The elements are 1, 2, 3, 4, 5, 6. So 1, 2, 3. Here 4, 5, 6. Let us calculate 2 or 3 entries. 2, 2. So that means what we need to find? This 2 into 2. That is 4. Now 4 divided by 7. So it will be 4. Now consider 3 and 5. So 3 into 5, because it is a multiplication modulo. So 3 into 5, that is 15. And 15 divided by 7. So remainder is 1. So here it will be 1. Now 5 into 4. So 5 into 4 is 20. 20 divided by 7. So we'll get remainder as 6. So 6. So this is how you can calculate all the entries. Now again, it is what we need to find the abelian group. So closure property. So as you can see that this all the entries, they are from what, this the given set G. So it is the closure one. So it is very obvious what all the entries in the composition are elements of the set G. So it is closed under multiplication modulo 7. So that is x7 or cross 7, right? Now in same manner for associative property, everything is same. See, whatever we did in previous sum, it is same, but only the notations are different and some calculations are different. So A cross 7, B cross 7, C in same manner. Suppose we take example 4, 5, 6. So the left hand side will be what? 4, 5, 6. Now 5 into 6. So that is 30, and 30 divided by 7. So remainder will be 2. Now 4 into 2. So 6 remainder, 6 divided by 7. So remainder will be 4 into 2, that is 8. Now 8 divided by 7. So remainder is 1. Now here 4 into 5, 20. 20 by 7. So the remainder is 6. Now 6 into 6, 36. 36 divided by 7. So remainder is 1. So you can check for each and every entry, any 3 elements, so the answers will be same. So it is the associative one. Now for existence of identity. Now what is the identity? Identity element means one element, then that operation into, okay, the identity element will get the same element. So see, no need to check. Here consider this. What are the elements here? 1, then addition, multiplication modulo, and some identity element. We don't know what is that identity element, but the answer will be same. So as you can see that in the row of 1, where is 1? So here 1. So we have operated with 1. So here for 1, the identity is 1. And remember, identity element is unique for the whole example. Okay, but inverse element, they are different. So as you can see that here 2 operated with 1, we are getting 2. So in this whole column, we are getting the same elements as 4, 4, 5, 5, 6, 6. So as you can see that this 1, it is the identity element. Okay, so 1 is the identity element. So yeah, so hence it is the identity element. Now again for inverse. So consider again the table for inverse. For inverse, what we need to check? The element, then the operation, and what? And some element, and we will get the identity element. So identity element is 1. So here 1 and operated with some, so that we will get what? The identity element. So 1, and the identity element is 1. So here 1's inverse is 1. Now for 2, where is the identity element? Here 1, and corresponding to that element is 4. So 2's inverse is 4. Now here for 3, we have 1 here. So 3's inverse is 5. Now 1 here. So 4's inverse is 2. 5's inverse is 3. And 6's inverse is 6. So this is how the inverse elements are also there. So yes, it is done. Fine. And for commutativity, it is very obvious. So as the corresponding rows and columns are identical, it is commutative. Fine. So here all the 5 axioms are satisfied. So we can say that this G multiplication modulo 7, it is an abelian group. Thank you.